Okay, so these last two videos before you go on Thanksgiving break, I decided to take a little bit from other units and put them into this unit so that we don't have to, so that we can end on a good test before we go on Thanksgiving break. That's why we're not in between a unit and we have to remember it coming back and struggle with that after the Thanksgiving break. So what I decided to do was add this definition of derivative. It's an alternate, it's a shortcut that you can do to solve these kind of problems that are set up in this format. And also I added exponentials and logarithms. And I'm talking about with bases that are of e and bases that are not of e. Okay? And then the same thing over here. Logs that have a base of e are the same as a natural log. So if you don't remember from Algebra 2 and Pre-Cal, a natural log base e is the same as natural log. So we're talking about natural log of x's and logs that are not bases of e, like log base 2 of x. So what we're going to do is we're going to learn these four rules of differentiation. So exponentials with base e, exponentials without base e, and they're going to be pretty involved as far as like chain rule and whatnot. You'll see as I do the examples here soon. And then natural log, which is logs of base e, and then log like base 2 or log base 4 or whatever other base that you could have. So those four rules of differentiation along with this alternate way of solving it, and I don't mean the alternative form of the definition, I mean it's just a different method that you could use to shortcut these kind of problems. So let's go ahead and get started with these limits first. Now the old school way would be that you would distribute this Pascal's triangle wise, distribute the two, and it would simplify to an answer. Okay? And I'm going to do that real quick. If you need to go back and see Pascal's triangle, I would say Google it, whatever you need to, but this is the Pascal's triangle form for this. Its cubes, so the coefficients are 1, 3, 3, 1. Because it's addition, all of these will be addition. And then it's just going to be x cubed, x squared, x to the first, x to the 0. Then you start backwards, h cubed, h squared, h to the first, and h to the 0. So if I simplify the top and multiply it with this 2 that's in front of it, I will get 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus this 2x cubed here at the very end. Okay, and this is all over h. Well, from here you should see that this will cancel with this to a form of 0, and then this h is going to reduce all of these so that I have left over 6x squared plus 6xh plus 2h squared. Now, way back when we did these problems, and I said you just cancel the denominator, what is the next step? Well, that is when you plug it in. So you just canceled. So the next thing is to rewrite this limit, and then you would then apply this here and here so that your answer would equal 6x squared. And what did it represent? Well, it represented the derivative of the function. And we wrote f prime of x. I know it's been a little bit, as far as, it's been a little while since we've been doing stuff long ways like that. But you would get 6x squared as your answer. Now let's come back over here. Let me show you the shortcut route. Alright, so it is f of x plus h minus f of x. The only difference that exists between these two, basically y2 minus y1 functions, is this h. Everything else is the same. Now, what does that mean? Well, if this is my f of x function, well, let's just assign it. Let f of x equal 2x cubed. And I got that from up here corresponding with the placement in this fraction, if you will. So if f of x is equal to 2x cubed, all I have to do is just take the derivative, because that's what this is doing. It's trying to find the derivative. So f prime of x is equal to basic rules of differentiation. Look how much faster we can get to the answer based upon what we know now of rules of differentiation. And of course, the definition of the derivative of what this truly means. Okay, let's do another example. All right, so notice here, I have, let me take this off. I don't want to have that pre-filled. I have f of x plus h minus f of x. So I'm going to assign f of x, so let f of x equal the cosine of 5x. Therefore, f prime of x is just going to be the derivative to get negative sine of 5x times 5, because it's chain rule. So that simplified form, f prime of x is equal to negative 5 times the sine of 5x. That is the answer. Basically, this is what I would write right here from way back when, and I would have circled the whole thing. But the answer is negative 5 sine of 5x. Okay? Now, that's a way that we can do it to show, to basically do the shortcut so that we don't have to do the long route. And the long route is looking at this thing right here. It would involve cosine of 5x plus 5h. Okay? And 5x plus 5h becomes pretty involved in the fact of you're going to do an identity. And the identity is, it's like the cosine, sine bit. And that's from the identities formula chart. A lot of you probably won't remember that, and I don't expect you to. That's why I'm showing you the shortcut of how you can assign f of x as your function to get to the derivative, which is going to be negative 5 sine of 5x. Okay? So let's now go to our last one. Well, this right here is f of x plus h minus f of x. Okay? What already is different from the two problems that we've done is, if you notice, when I was looking at f of x plus h, it had a variable of x cubed right there. Let me do it in a different color. So x cubed right there is that variable. Here it's 5x. There's another variable of input of x. Okay, and it's corresponding to this x that we're setting it to right there and right there. But what happens when you don't have an x, where you normally would see that f of x function? Well, you have to create one. So I said it's f of x plus h minus f of x. The only difference that exists in between the two, and I said it way back here, was this h term. So let's find this h term right here. That's the only thing, quote unquote, different between f of x plus h and f of x. So that means this is sine of x plus h minus, technically, sine of an x. Okay? Again, the only thing different should be that h. So if that is true, that means sine of x is equal to 1/2. And we know that is the case if and only if this input value is pi over 6. So what this is really asking you to do, it's a two-step process. Okay? It's asking you to first let f of x equal the sign of a variable. Okay? Because if f of x is equal to 1/2, if we did that, which a lot of people mistakenly do, when you take the derivative, it's always going to equal 0. And here's the thing, it doesn't always equal 0, because then any of them with a constant would end up equaling 0. So we have to go a little bit step further and change this input value that creates this 1/2 and this input value that shows my input value is pi over 6. This is my at value. Okay, so we've done a lot of problems by now. Like if you were given a point, that would be your x value, the one that you're evaluating it at. Okay, so f of x is equal to sine of x. F prime of x, we would derive, is equal to cosine of x. And then this is where this pi over 6 comes into play right here. We know that sine of pi over 6 yielded this 1/2. But what I'm trying to do is I'm trying to put in this pi over 6 right here, so that I can say what is the derivative evaluated at a specific point. So the other ones, they just wanted the derivative. They didn't go further to see at a specific point. The answers that we found were with a variable in the answer. This one will be different because we're going to actually plug in this pi over 6 that we had to basically decode and see when and where it's going to be plugged in. So that my answer is a positive root 3 over 2. So the answer would be positive root 3 over 2 for this whole thing. And again, the shortcut route would allow me to do this much easier if I understand how to set it up. It's all about the assigning f of x be a certain function. In this case, it was sine of x. So if you need to rewind that, go ahead. Now let's move on to natural logs. Okay, so I told you we're going to learn natural logs and we're going to learn exponentials, both with bases of e and both without bases of e. So what we're going to do first is we're going to learn logarithms and exponentials with the base of e. So let's start with the natural logs. Okay, so log base e is the same as natural log. Okay, some rules to memorize for you to know. The natural log of 1 is equal to 0. And if you need to refer to the parent function, I would definitely do this if you can't remember all that stuff. And just remember that this is the natural log of x. And it goes to the point 1, 0. So if I were to say the natural log of 1, well, what would the answer be? Well, it would be 0, which is my output value on the parent function. Natural log of e, you should know by now, cancels each other out. It's like saying the log base e of e. What would that equal? Well, something that I'm going to introduce right now, if you struggled with logs and exponentials, is that if you have something in log form and you wanted to solve it, you should rewrite it into exponential form. So basically, if you're given something in an exponential, rewrite it as a log and it'll be easier to solve. Vice versa, if you're given something in a log form, rewrite it in exponential and it's probably easier to solve. For instance, right here, the log base e of e, if I were to rewrite this, I'm going to use something called the reverse heart method. So I would start at the base and I'm basically going to counterclockwise draw a nice little heart. And it's like a sideways heart if you tilted your head to the right. Okay, so looking at this, e to the power of question mark is equal to e. Well, what would question mark have to equal? Well, for this to be true, question mark would have to equal 1. Therefore, the natural log of e is equal to 1. Okay? E is the number that we will discuss here very soon. It's 2.71828, and it goes on and on. It is a constant similar to pi, if you will. And it's basically saying if this is 1, this is 2, at 2.71828, its y value, so let's put this as e, will be 1. Okay? We'll discuss this more as we go throughout the year, but for right now, I'm giving you basically just the overview for rules of differentiation purposes. Okay, so now let's look at the other rules. The natural log of a product is the same as the natural log of a plus the natural log of b. Now we have learned this from Algebra 2, rules of, or law of logs. Natural log of a quotient is the same as taking that and subtracting the natural log. It's like you're applying the natural log to both of them. You're not distributing because there's no multiplication going on, you're just applying. And then this property as far as where you can change its power of the argument, which is a. So a to the n can move basically as a coefficient, so it's on the it's on the same level. Nice and pretty as far as n times natural log of a. So there is multiplication between n and natural log of a, but there is not multiplication between natural log and a. It's the natural log of a. Alright, so let's go ahead and see what we remember as far as law of logs, if you will. What we want to do is write as a sum, difference, and multiple of logs. So what I see right now, big picture wise, I see the natural log of this huge quotient. So I can rewrite this as the natural log of the top minus the natural log of the bottom. So we'll put natural log of the cubed root of x squared plus 1. And if you don't remember, cubed root is the same as, like this, is the same as x to the 1/3. So let's say the cubed root of x squared, Just a little review from Algebra 2 rules. This is x to the 2/3. So the power goes on the top, and the root goes on the bottom. Okay, so this we can write as 1/3. Okay, but we want to write it as the sum and difference of multiple logs. So what I can do here even further if I wanted to expand it is move this down so that I had 2 natural log of x squared plus 3 minus 1/3 natural log of x squared plus 1. Now, that's all you can expand it. You can't expand it any further than that because of the fact that these are not multiplication or division occurring. So we'll just leave it like that. Okay, just a little bit of recap or review from Algebra 2, Law of Logs skills. Right, as a single log. Here we go. So as a single log, we're going to basically combine everything and go the other way. So this becomes natural log of x plus 3, argument squared, plus 1 over 2, natural log of x minus 2 to the 1/2, which is the same as a square root. And if I were to simplify and combine them, because they're logs with the same base, which is e, I can combine them when they're adding like this to 1 log. And that will be multiplication. Because this is addition, what will exist between these two arguments will be multiplication. So I'll have x plus 3 quantity squared, and it's multiplied with a square root of x minus 2. And I can say it like this. So all that multiplied, it's basically the natural log of that product. So x plus 3 squared times that square root of x minus 2. And we could stop there for just review purposes as far as writing it as a single log. Now here we go. Exponential and logarithmic rules. What we will do in this video are the following. We will do the natural log, and we will do the e to the u. We'll save these for the last video. Okay, so we're going to do these right here that I'm circling right now. These are the ones that we will include on this video here. So what is the rule of differentiation? The rule of differentiation is the following. If I have the natural log of something, and I'll call this something u, it's 1 over that something times the derivative of the cream. So there is definitely chain rule going on here. The e to the u is e to the something. It's just basically repeating itself. So it's like a carbon copy, if you will. And it's going to be multiplied by du dx, the derivative of the power. So here we go. So the natural log of stuff is 1 over the stuff times the derivative of that denominator piece, if you will, or that argument that you saw in the original one. Where this rule of differentiation with e to the u, we will see the proofs after Thanksgiving most likely, but I'm just wanting to get these in for test purposes as far as you learning the rules of differentiation. The derivative is carbon copy, if you will, and it's multiplied by the derivative of the power. Now, let's go ahead and start working some problems. Let's do the natural log first. Notice a caveat as far as 1 over u, as long as u is greater than 0. As long as it's basically not equal to 0 is the bigger thing, because you don't want an undefined piece. Okay, the reason why it's greater than 0 is the fact of the natural log of u, or the natural log of x, if you will. The way we drew the parent function, something to really be careful of is to know the domain of the parent function. It's x's that are greater than 0. That's what you see here. Or another way you can write it is 0 to infinity, open, open. It is undefined here at x is equal to 0. The domain is only everything after 0. Okay, and that is something that is subtle but huge and important when you go to check your answers and whatnot for domain restrictions on a natural log function. Okay, so what is the derivative rule of differentiation? So it says 1 over the stuff times the derivative of the stuff. Well, what's the derivative of 2x? 2. So if I simplified this, it'll be 2 over 2x, which is the same as 1 over x. So my answer for this guy right here is going to be the derivative f prime of x is equal to 1 over x, and I'll write it out just like that. Okay, so let's go now to the next one. It will be 1 over the stuff, so 1 over x squared plus 1, times the derivative of the cream. So what's the derivative of this inside stuff? It's just like chain rule. It's going to be 2x. So that y prime is equal to 2x over x squared plus 1. Now don't think that you can cancel those x's, because you cannot, because of the fact that the bottom is not a monomial piece, it is a binomial piece. And what you know from cancellations with multiplications, that will not cancel out. So that is your answer, 2x over 2 over x squared plus 1. Now we'll go to the next one. The next one has a little bit of product rule in it to it. So it has the first times the derivative of the second, which is 1 over x, plus the second times the derivative of the first. Well, what's the derivative of x? It's just 1. Remember, it's an understood. You're taking it in respect to x right here if you're not told otherwise. Okay? The only time it's in respect to t is when it's a related rate problem, something dealing with time. Okay? So looking at this doesn't deal with time. It's just x times natural log of x. So we can take it in respect to x as a default, and then you would get this simplified, or you would get this answer here that we're going to simplify right now. So the first times the derivative of the second reduces to a form of 1, and then it's going to be adding with natural log of x times 1. So my answer is just 1 plus natural log of x. That is the derivative answer. Alright, so let's keep going. I would rewrite this. Chances are that I would say f of x is equal to natural log of x plus 1 to the 1/2. Or you could write it as 1/2 natural log of x plus 1. This is further going with law of logs and moving that power out in front as the coefficient. And yes, it is multiplied right here. So there's many ways that you could do, or here, 2 ways that you could solve this out. So let's take this one. It will be 1 over the stuff, which is x plus 1 to the 1/2, times the derivative of the stuff. So the derivative of stuff is chain rule. 1/2 times x plus 1 to the negative 1/2 times the understood 1 coefficient that exists in front of that x. Now how does that all simplify? Well, immediately I see this negative power. It tells me that this is going to be in the denominator. So it will combine with this one over here to become just x plus 1. So it should simplify to 1 over 2x plus 1. And if you wanted to, you could write it as 1 over 2x plus 2 if you wanted to have it without parentheses. So either way, these are the answers. Because of time, I'm not going to keep writing f prime of x is equal to for the video, because I don't want you to see a long video, so I just leave it like that. Let's go to now this one. If I rewrote it all the way here, I could say 1, here we go, 1 over the stuff. What I'm doing is I'm constant multiple ruling this 1/2 out. And then it's going to be times the derivative of stuff. Well, the derivative of this is an understood 1. Then constant multiple rule the 1 over 2 back in. And you see by now, you're going to get the same answer that you see over here. Any one of those two that you could write. So 2 different ways to do it, depending upon your preferences. Alright, so this one has a chain within a chain. So the stuff is natural log of x. So right now I'm going to say 1 over that natural log of x that I highlighted in green. Okay, 1 over the stuff times the derivative of the stuff. So I'm going to treat this inside cream, if you will, or the Oreo cookie example that we compared it to, as another problem. So the derivative of natural log of x all by itself is 1 over x. So y prime is going to equal 1 over x natural log of x. And you can write it like that if you wanted to. And some of you might actually rewrite it to say, well, I know law of logs, I can rewrite it as the natural log of x raised to the x power. If you wanted to do it like that, that would be fine as well. Because you know law of logs as far as that coefficient moving if you wanted it to. Alright, so this one. This one's chain. So the derivative of the outside is 3 times the stuff to the second, okay, times the derivative of the stuff, which is 1 over x, and then that's it, okay? So if you wanted to simplify this, you can if you want. It would be 3 natural log of x squared, which again, law of logs, if you wanted to move this, actually I'm realizing right now, natural log of x quantity squared is not the same as natural log of x squared. Because this, the way it's written, is only applying to the x. This, the way it's written, is applied to everything. This almost feels that I could write it as natural squared of x. Those of you who have had difficulties or understand the whole sine squared of x is the same as sine of x quantity squared, if you wanted to help remember as far as how this is going to be interpreted, you can think of it like this, but please do not write it like that. You're going to write it as far as the way it's shown over here. Okay, so it's going to be natural log of x quantity squared, so you cannot move this 2 over. You cannot move it in front to write it as 2 natural log of x, which will then multiply by the 3. You cannot, because of the fact it's not in this form. So if it said natural log of x squared, you could. If it said natural log of x in parentheses squared, you can move it. But if it says natural log of x quantity, the whole thing squared, you cannot move that 2 out in front. That's not an applied equivalent of that law of logs. So I would leave it the way you see it, and it would reduce to 3 natural log of x quantity squared over x. And please, please, please do not try to cancel out an x right here, okay? Because of the fact, again, there does not exist multiplication between that natural log and x. It is just composition, if you will. It's like sine of x or cosine of x. It's a function that you do not apply. That there's no multiplication occurring. Okay. So just like I said, the difference between these two is this one is interpreted as this, if you will. So I can move this 3 because it's only being applied, again, to the argument. If you need to rewind this video, you can. So from here I can say, well, what is the derivative of natural log of x? Well, it's just 1 over x. Constant multiple rule that 3 back in, I'm going to get 3 over x. So this should be the derivative. Let's work it out the other way. Let's say that it's 1 over the stuff times the derivative of the stuff, which is 3x squared. So this would reduce to 3x squared over x cubed. They can cancel here because there's multiplication occurring, and you would get 3 over x simplified out, which is what we originally got, doing it a different way. Okay? So again, you should see that it's similar to other problems that we've done in the fact of if you rewrote it a certain way, how does it make it different? And how does it make it easier? Alright, so by now, again, this is the rule of differentiation for natural logs. I want to write the equation of the tangent line, and it's basically the same thing. And we're going to use it as, or at this point of 1, 0. So my goal is, if I want to do the equation of the tangent line, I know it's this one right here. And I know that I already have an x, and I have a y value of 0, which would go here. I just need to find a slope. And the slope is going to be the f prime of x, evaluated at 1. So m will become f prime at 1. Okay? So here's my f of x function. It says y is equal to this. So let's derive it. So that I say y prime, or f prime of x, we know this by now, is equal to 1 over the stuff times the derivative of the stuff, which is 3x squared. Okay, the function does reduce to something we just saw in the last example. This is the derivative. And then if we put in this 1, let me get it highlighted in green. If I put it here, because I'm looking for f prime of 1, we're going to say f prime of 1 is equal to 3. so that it's going to be y minus 0 is equal to 3 times x minus 1. And you can write it like that if you want. Or if you wanted to simplify, you could say 3x minus 3, however you wanted to do it. This will be your answer for the equation of the tangent line. If it said normal, it doesn't, but if it did, right here, this would be a negative 1/3, and everything else would be the same as far as at this point in time. So the only thing that you would change is the negative 1/3, and then if you wanted to distribute that out, it would be negative 1/3 plus 1/3, because it would distribute to that negative 1. So if it was the normal, this would change to y minus 0 is equal to negative 1/3 x minus 1. So it would be negative 1/3 x plus 1/3 if you put it in y-intercept form, or in slope-intercept form, however you want to see that. All right, so write the equation now of this one. So just a little bit more practice. I'm thinking constant multiple rule. So the natural log of x is just 1 over x. I'll multiply the 5 back into it, so I get 5 over x. And then it's going to be minus 3x squared. This is y prime, or f prime of x. Okay? I'm going to, in this derivative function, plug 1 here and here, so that I get 5 minus 3. So the slope, f prime of 1, is equal to 2. So it'll be y minus y1, which is right here, so it's going to be plus, because it's subtracting the negative, is equal to this 2 that I found of the slope, x minus 1, because it's that x value right here. And that would be your answer for that one. Alright. Now let's do some implicit differentiation with natural log. Notice that my respect goes to x. So we have 3x squared, just as normal. And then here we have a y. Constant multiple rule, the 2. So I'm going to look at 1 over the stuff times the derivative of the stuff, which is dy dx. Otherwise, y prime, if you will. And then multiply the 2 back in. All this right here is my second piece, if you will. Okay, all that is this. So 1 over the stuff times the derivative of the stuff. Plus, alright, so it's going to be 3y squared dy dx. That chain rule piece, again, implicit differentiation, is equal to 0. So I have 3 terms, and if you remember what we did when we first started this unit with implicit differentiation, the key was to identify all the terms that you have and see what you're going to move over to the other side of this equal sign. So I'm going to subtract the 3x, and then I'm going to GCF out a dy dx on the left side. So dy dx, you have a 2 over y plus 3y squared. Okay, and that's how everything else was GCF'd on the left side. And then I'm going to have a negative 3x squared because I moved it over on the right side of the equal sign. And right here, if you wanted to, you could divide them both by the same thing. Or if you wanted to combine this, you could say, let me get a common denominator of y. Okay, so I'm going to multiply by a form of 1. So that I get, this is 2 over y plus 3y cubed over y. And if I combine this, I'll get 2 plus 3y cubed over y. Because the chances are, if I move it, negative 3x squared, my final answer is probably going to look like, all right, I'm going to divide by this, so it's multiplying by the reciprocal, negative 3x squared y all over 2 plus 3y cubed. This is probably the form that you'd see it in if it was multiple choice. Okay, and yes, we are done, and it is correct because of the fact that it's written in terms of x and y, and that's all that you see over here. You don't see any y primes dealing with like second derivatives or anything like that. Alright, let's do some e to the x now, exponentials. So exponential functions that we're looking at, first of all, a little quick review. Just like I showed you what the natural log of x looks like, e to the x looks like this. Because again, they reflect across y equals x. So the natural log of x was way down here, and its reflection across y equals x, because they're inverses of each other, would be e to the x. This is 1, 0, and yes, you guessed it right, this would be 0, 1. Okay, and again, the other one would be if this was 1, where would it be on the e to the x? Well, it'd be here, and that would be that constant that I discussed earlier, 2.71828, and it goes on and on, 1828. It says 2.71828, 1828, then there's a lot of other numbers. It doesn't repeat 1828 forever, but it does first couple times. All right, so this is just a vertical shift 3 units up. So instead of 0, 1, it will be at 0, 4. And it would shift my horizontal asymptote as well. Instead of y is equal to 0, it would have it at y is equal to 3. So your function looks something like that. E to the x plus 3. It's just a shift 3 units up. Again, this would be at 0, 4. This is just a little review, so we are familiar with the e to the x. Now, e to the negative 2x, this is going to show the negative is in front with the x. So when the negative is with the x, it's saying all the x values are jumping across, back and forth, reflecting across the y-axis. So ultimately, the very first thing that would occur is this would change to reflection across the y-axis, which would look like this. The other thing is the 2, again, first glance looks like a stretch, but because it's with the x, we're going to do the opposite, okay? So it's not a stretch by 2, it's going to be a compression by 1/2. It's going to be a compression by 1/2 on the horizontal. So horizontally, it's a compression. So if this is 0, 1, horizontally, it's going to multiply by 1/2. Nothing happens x-wise, but all these to the left would get closer to the y-axis. And all these to the right would also get closer to the y-axis, and it would look something like that. Okay, that's just a little quick review with transformations. Now let's look at the rule of differentiation. It is the carbon copy times du dx. Okay, du dx is because this could be something other than x, and we have to do that chain rule piece because we're in respect to x. Let's see what that means. That means u is more involved than just one letter. Look at that. It's a composition. It could be made up of 3x squared or 3x squared plus 1. It's not just one variable. That's why whenever we do it, it's going to be y prime is equal to the carbon copy times the derivative of the power. So what is the derivative of this power? Well, it's just basic differentiation would be 6x. Okay, and know this, they are all on the same line here. Okay, it's like 6x is not in the exponent. 6x is like the coefficient downstairs, if you will. So if I wanted to rewrite this, I'd write the coefficient and probably x first, and then e at the very end, just like you would do sine, cosine, or tangent at the very end, grouping and simplifying things that we've talked about in the past. And yes, there is multiplication occurring there. You don't have to do those dots. You can write it as 6x e to the 3x squared. And I will not interpret this as 6 times e to the 3x squared. I will understand that you're multiplying by an x. All right. Next, we see a product rule. So I have the first times the derivative of the second. So I'll separate them with some parentheses. And the derivative of the second is, we just learned the rule, carbon copy times the derivative of the power. The derivative of the power is negative 2. So I'm going to multiply by negative 2. So let's go ahead and put that. And it's going to be adding, so first times the derivative of the second plus the second, so this is where parentheses come into play, times the derivative of the first, which is just 3x squared. So looking at all this, we know that we are not going to have negative powers of any kind, okay? And right now I do have negative powers. So if I were to write this, y prime is equal to, know that this whole negative power would move downstairs, essentially, and you would have it written simplified form as, let me write it up here, y prime is equal to negative 2x cubed over e to the 2x. Okay? And it would be adding 3x squared over e to the 2x. And this would be an acceptable answer because then no longer do you have these negative powers that you had in the original one. They got moved downstairs and you made them a positive. Okay? And there aren't any complex fractions like square roots and stuff like that in the denominator as you see. And this would be an acceptable answer. Right here. And if you wanted to combine them as one fraction, as you could see you possibly could, then GCF an x from the numerator you can, but it's not required unless it's a form of manipulation that you have to see with multiple choice answers. Alright, here we go. Now we're going to combine them both. F prime of x is equal to, so 1 over the stuff, big picture wise it's the natural log differentiation rule first, so 1 over the stuff times the derivative of the inside. Okay, the derivative of the inside is, well, 0 for 5, but it is the carbon copy times the derivative of the power, which is just 4. So this simplifies all out to 4e to the 4x all over 5 plus e to the 4x. There aren't any negative powers, so you could leave your answer just like that if you wanted to. Okay? Again, don't cancel those e to the 4x's because of the fact of it's not multiplication going on in between all the pieces. That is a binomial on the bottom, so you do not cancel. It's a different factoring way to cancel that piece. Alright, find the derivative. First, second. So it's the first times the derivative of the second, secant squared x, plus the second times the derivative of the first, which is just e to the x times 1. It's an understood 1 if it's just one variable. So again, up to this point, this power has been involved. It's been more than just x. It's been like 2x squared or 3x squared or whatever, so you've had to do more with it. When it's just x by itself, you're multiplying by an understood 1. Otherwise, what we've been doing in this unit, dx over dx, because it's the derivative of this x, and I will highlight that in green, in respect to the x that is the default. Okay? So I will undo all that and just say it's an understood 1 by not writing it. Okay? So this is y prime. And if you wanted to see this and write it out by combining them, or GCF this e to the x, you could do that if you want and have secant squared of x plus tangent. That's another way that you could see it as far as an answer y prime if it was manipulated multiple choice wise. Alright, so the next one's a little bit involved. It's our first one that is pretty lengthy. And the fact that we see we're going to have quotient rule. Okay? We're going to have quotient rule. We're not going to move this bottom up. A lot of people have been trying to do that because of the fact that the top is not just a constant. It's pretty involved. Okay, so let's go ahead and do the quotient rule. So it's low d high, and d high is the carbon copy times the derivative of the power. So I'm going to go ahead and write that in front. So I'll say 3e to the 3x. Okay, so it's low d high minus high d low. Okay, d low, the 4 becomes 0. And again, carbon copy times the derivative of the power becomes another form of 3e to the 3x. All over low squared. So that would be this plus 4 quantity squared. Alright, and just again, I keep wanting to try to eliminate all the possibility problems that people make mistakes with. So a mistake would be making this 2 distribute to be e to the 6x plus 16. Believe it or not, some people do that. If it was multiplication, that would be correct. But because it's not multiplication, you don't apply them to them apply it to them individually, because you're supposed to interpret the bottom as e to the 3x plus 4 times e to the 3x plus 4. Okay? But you don't have any negative powers. Everything looks good right now. I would definitely accept this answer. Of course, that equal to y prime. We are almost done, guys, with this. Yep, last, and this is, again, the second to last day before you go to Thanksgiving break. So write the equation of the tangent line. So we'll find y prime. This is exponential, so it's carbon copy times the derivative of the power, which is 2. So this is 2e to the 2x is the derivative. And we're now going to evaluate it at 0. So e to the 0, anything to the power of 0 except for 0 as the base or infinity as the base, anything else will equal 1. Okay, so this is 2 times 1, so the slope is y prime, otherwise known as f prime at 0, is going to be 2. So it's going to be y minus 1 is equal to 2x minus 0, or if you wanted to simplify, you could say 2x plus 1. Point slope formula or just regular y-intercept formula. Alright, now our last one. The respect is given to x. So we have normal 3x squared plus product rule, the first times the derivative of the second. So you go e to the y times the derivative of the power, dy dx. So e to the y dy dx plus the second times the derivative of the first, which is an understood 1. So let me move this over just a little bit. And then it's minus 5y to the 4th dy dx. Okay, because we're in respect to x is equal to 0. So I'm going to look at this again. Let's look at our adding and subtracting symbols, and we know from that having 3 of those shows that we're going to have 4 monomials. The only 2 that have dy dx, you can move it to whatever side you want. I'm going to leave mine on the left side, are these. So that I GCF that out, I get dy dx is multiplied with x e to the y minus 5y to the 4th. Okay. And on the right side is going to be moving this 3x squared, so let's say negative 3x squared, and moving this e to the y, minus e to the y. And of course you can see that I'm going to divide right now. So then my final answer becomes dy over dx is equal to negative 3x squared minus e to the y over x e to the y minus 5y to the 4th. No negative powers, no complex fractions. There's your answer.